Hello everyone. Today we are going to learn about the data structure which is graph. A graph is nothing but a data structure that consists of a set of nodes and set of edges. Nodes are nothing but vertices and the pairs are the connecting pairs of nodes. There are two components of graph as we said earlier, vertices and edges. Vertices are the individual elements or entities in the graph and edges are the connections between the vertices. Depending on the connections, there are multiple types of graphs. First, directed and undirected graph. When the graph contains undirected edges, then it is called as undirected graph. What does it mean? Here, in this diagram, there are multiple edges between A, B, C, and D, but none of the edge is having arrow. That means it is an undirected graph. On the contrary, here we can see that there is an arrow from 11 to node 1, from node 9 to node 7, node 11. These are called as directed graph. Now, what is complete directed graph? In complete directed graph, every vertex is directly connected to every other vertex. Here, as you can see, it is a directed graph, and node A is connected to node B, node C, as well as node D. Okay. Now, complete undirected graph means every vertex is connected to another vertex, but it is undirected graph. There is a formula for calculating the number of edges. If the number of vertices is n, then the number of edges in complete directed graph will be n into n minus 1, and in undirected graph it will be n into n minus 1 by 2. What are adjacent nodes? A node is called an adjacent if there is an edge between two vertices. In the example given, this is undirected edge. So A is the adjacent node of B and B is adjacent node of A. But here it is directed edge. So B is the node of adjacent node of A, but A is not the adjacent node of B. Now path. What is a path? A path is a sequence of vertices that connects two nodes in a graph. Suppose we want to grow from D to B. So there are multiple paths. We can either go from D to A to C, C to B, or we can go from D to A to B, or D to C, C to B. There is another concept called cycle. Cycle means that if a path starts from a node and ends on that same node, then that is called a cycle. Here you can see that this is node D. I can go from D to A to C, and again from C to D. The starting and end vertex was same. So it is cycle. What is weighted graph? In weighted graph, we assign some value to the edges between the vertices. Connected graph. In the connected graph, there exists a path between every pair of vertices that may be direct or indirect. Here you can see there is a path between A to C, C to B, A to B, and C to D direct. But we can go from A to D following the path A to C, C to D. Here in this disconnected graph, there is no path between A and D. So this is called a disconnected graph. Subgraph. A subgraph of a graph G is such that there is a subset of vertices and subset of edges. Here the graph is G and it is subgraph G1. We have subsets of vertices, that is A, B, and C, and the edges connect between them. It is not necessary that you should include all the vertices or all the edges. It is subset of vertices and edges. Degree of vertex is the number of edges connected to vertex. There are different types of vertex in degrees. In degree means the number of upcoming edges to a particular vertex. Out degree means number of outgoing edges, and sync means there are only incoming edges and no outgoing edge. In source, we have only outgoing edges and not incoming edges. In this example, node D is sync because there is a graph, there is an edge from C to D and A to D, but there is no outgoing edge from D. In this diagram, as we can see, there is no incoming edge for node C. So this is the source where all the edge where only the edge originates and does not sync. Pendant means having only one in degree and out degree 0. Isolated means the degree is 0. There is no incoming, no outgoing vertex, no outgoing and no incoming edges. Self loop means an edge from V to V is known as self loop if there is an edge from a node to that node itself, then that is called a self loop. Multigraph means having multiple edges between two edges, between two nodes. Spanning tree. So, spanning tree is a subgraph of G having all the vertices of G and no cycle in it. Here you can see in the diagram there are three nodes G, I, and H. There can be multiple spanning trees G and G to I, I to H, I to G, G to H, and here G to I, I to H. Here, what is compulsory is that we need to add all the vertices. We can eliminate the cycles. We should eliminate the cycles. Minimal spanning tree means that the cost of all sum of edges, cost of the graph should be minimum. The cost is defined as the sum of the edges in the graph. In this spanning tree, the cost is 7 plus 3, that is 10. We can find multiple spanning trees of this graph, but the cost will be minimum for this particular one. So this is called as minimal spanning tree. There are two ways of representing a graph: adjacency matrix and adjacency list. Adjacency matrix is a n cross n size matrix where we represent all the nodes horizontally and vertically, and for each row we have this node 0. So we will look what are the outgoing edges from this node. From the node in node 0, there is an edge to 1 and also to 3. So we'll mark 1 for 1 and 3. If there is edge between two nodes, we'll mark it as 1, else we'll mark it as 0. For another example, there is this node 4. There is only one edge from 4 to 3. So we will mark 4 and 3 as 1. For the undirected graph, it will be same, but the edge will be same for both A to B and B to A. In case of a weighted graph, if there is no edge between two nodes, then we will mark it as infinity, and if there is self loop, then we will give that weight itself. Otherwise, we'll mark it as 0 because self loop of it is itself is 0. Otherwise, if there is an edge from 4 to 3, something like that, then we will directly enter that weight. Adjacency list is nothing but a representation of one-dimensional array of linked list, where the node of linked list contains all the nodes in the graph, which will point to all the adjacent nodes of that particular node. Here you can see that from the node 0, there are two adjacent nodes, 1 and 3. So for node 1, node 0, we'll mark 1 and 3 and connect it via linked list. The sequence doesn't matter. There is no particular order. We can have it in any order. Same for the weighted graph. We will have the name of the node, the weight of it, and the link joining to the next node.